intro. Thank you.
Okay, everyone, our next speaker is Ivanitskiy of SmartDec, Limitations of Smart Contracts.
Thank you. Hi friends, thank you for coming. I'm happy to be here at ETH Denver. And my name is Ivanitskiy. I'm Chief Analytics Officer at SmartDec, and today I will share my ideas on limitation of smart contracts with you by describing 8 controversial use cases. So first, a few words about our company. We are SmartDec, a security company. We create static code analyzers. We perform smart contracts audits, which we have done like more than 164 now. Also blockchain audits, second layer solutions, and blockchain consulting. You can try our tool, security tool for Viper and Solidity, which is SmartCheck. It's available online and free, and also our blog and other stuff. So I have been to a number of Ethereum conferences as well as enterprise blockchain conferences. Also, I have a lot of conversation with my friends, and all these things led me to a thought that there are several popular misconceptions in understanding of possibilities of smart contracts and blockchain, and that lead me to trying to fight these misconceptions, and I try to summarize them in several use cases and their problems. So I will describe these use cases, their problems, and also I'll share some considerations and dreams. So a bit of disclaimer. Describing these use cases, I do not state that they do not work. I do not state that this is impossible to do that. I only say that they have problems, and these problems should not be ignored, because often they are. And also, since I don't have much time here, I won't dive into technical details. I will just stop at the level of business model here. So let's start with the first one, which is a pretty popular one: supply chain management. This use case is very wide. Here I will reduce it to a simple one, to a simple example taken from Do You Need Blockchain Work, which is great. Check it out, definitely. So here we have an example of some goods being transported from point A to point B by our contractor, and we want these goods to be cooled properly through all the way. So we put them in a fridge. We put a trusted sensor there, and a sensor publishes data to blockchain. Thus, we can track the temperature through all the way, which is great. Unfortunately, that won't work, because our contractor, if he's an attacker, he can put this sensor in a little fridge, thus saving energy on cooling all the goods. And we will see that the temperature is okay, it's low, but in fact it won't be. So here we come to a wider problem, so I'll take a step back and give some analogy here. So we have a great technology, which is blockchain or smart contracts, and we have a great use case, which is Internet of Things. Here we talk about Internet of Things because we talk about interaction between software and physical objects. Okay. Also, we have a great technology, which is wings, and we have a great use case, which is flying. However, unless one crucial thing was invented, flying with wings was not implemented by humans. It looked like that, and this thing never worked. It was never seen by anyone in the sky. And the crucial thing that was missing was an engine. And in our case, the crucial thing which we are missing for combining blockchain and Internet of Things is oracles. I think you can find a lot of interesting talks here about oracles. I won't stop in detail on them. I'll just say that we need them badly. So if we have oracles, we can combine blockchain and IoT. So then we can fly really up in the sky, and that would be really great. However, stating that we have solved that problem already and stating that we already can fly up in the sky won't be true. Okay, so going back to our example, we need an oracle to make this use case possible, and now it's not. Okay, the next one is pretty similar to the previous one. Principally, it's the same. However, it's usually suggested by different people and has a bit different attack scenario. So I decided to describe it separately. Let's say we have some rare and expensive object. It might be a watch, jewelry, a car. However, since I'm not interested in any of them, I decided to take a bottle of wine, for example, which I am interested in. So let's say we have some great vineyard which creates great wine and wants to prove to us consumers that the bottle we are holding in the hands is the exact bottle produced on that vineyard. So they create a token, they put a QR code on the bottle or maybe some sophisticated sensor they put in the bottle, bond the token to this sensor. And then, when they sell the bottle to the store, for instance, they also transfer a token. And when we buy a bottle, we get a bottle and a token. We check the correspondence between the bottle and the token, and we trace the whole history of this bottle up to the vineyard, thus proving to ourselves that this bottle is original. However, this will not work if a store is an attacker. Let's say a store manages to sell the original bottle to someone who cares a lot about wine but does not care about the token. It's definitely not us, because we are all blockchain-loving guys, we care about tokens. However, this store can sell an original bottle to someone without transferring the token, and then create a fake cheap bottle, copying the original bottle, because a bottle is a physical object, thus it can be copied. A picture on it, a QR code can be copied, a sensor can be copied, a chip can be copied, and information in the chip can be copied too. So we get a fake bottle with cheap wine, but we get a token which corresponds to this bottle. We check this bottle and we see that this bottle has came from the original vineyard. We try this wine, we don't like that, and we think that our perfect favorite vineyard has been spoiled, and we are upset. So who's the winner here? Definitely not us, and definitely not the owner of the vineyard, who has lost his or her reputation. Okay, and what's missing here? Right, oracles. The next one is a better one. I think it's a pretty real one. It's a statement authenticity guarantee. The previous one was object authenticity guarantee, and here we come to statement authenticity guarantee. And let's take a university diploma as an example, because a diploma is actually a statement that this person has graduated from this university. Well, what we need here is a digital signature from let's say professors who teach that person, who prove the fact that he or she has actually graduated. And also we need timestamp in here to avoid the scenario when someone signs a diploma and creates a diploma in the past, so that we could be more sure that this diploma is authentic. So smart contract looks like a perfect solution here. However, I need to say about two things. First, if we create a good blockchain smart contract system for checking these diplomas, but we create a centralized interface for it, for instance, a simple website, then this website will be a single point of failure, because its administrator would be able to give us false information. For instance, to prove that false diploma is not false. Thus, we need some reliable interfaces. For instance, it might be just a simple wallet, for instance, for checking transactions. And also, the thing here is that actually just simple Bitcoin blockchain is enough, because we can take a hash of the signed diploma and put it in a Merkle tree and put it in the Bitcoin blockchain, and that's enough. So no need for implementing any smart contracts or any separate blockchain here. Okay, the next use case is much more controversial. It's voting. And talking about voting, first we need to understand which problem we are trying to solve right now. So there are two principal problems for blockchain and smart contracts to solve here, which are authentication and public vote counting. Okay, authentication is a good thing. We want to be sure that a person who votes has a right to vote, actually, that this person is this person. And asymmetric cryptography, private and public key pair, is a perfect solution here. several points here I will need to show you. First, key generation must be implemented on a user device. This is pretty obvious for us, crypto community. However, for enterprise blockchain guys and even more for government guys, this is not obvious. They often suggest to generate keys on by the central entity and then to give them to someone, which for me is nonsense. Also, this key should be generated by open source and well audited software to avoid security issues like vulnerabilities and backdoors. The same applies to hardware also. And even more important thing here is user skills. So we are all used to managing private keys securely. However, mass users, I think, are not, because often, even now, people create passwords like QWERTY and so on. So to make this voting possible, we need first to teach people to manage private keys properly. And the last problem here is a person-to-key correspondence. So we want to be sure that there is a person who has a right to vote, and exactly this person votes. And this means we need an oracle here because it's about real-world object. Okay, let's get to another problem, which is public vote counting. This is a good thing because due to public vote counting, we can be sure that vote counting was fair. First thought that appears here is that it might become too public if anyone knows for whom I have voted. However, this problem is already solved, but there is a more complicated problem. For instance, I have voted for some candidate and I have a possibility to prove that I have voted for this candidate. Then, in case someone has power upon me, this someone might want to make me vote for a correct person. And then, if I have a possibility to prove that I have voted for correct person, I can be enforced to do that. If I don't have such a possibility, if I can't prove for whom I have voted, then there is it's just useless to try to force me to do that. And also there is still a problem of person-to-key correspondence, which is solved by oracles, which are not present. Okay, this is just a meme for me to take some water. Thank you. Okay, the next use case is land registry. Let's say we want to track land ownership using smart contracts, which looks like a great idea. However, we have some major problems here. These problems appear due to the fact that land is not only a physical object, it's unmovable physical object. So I can pass a car to someone else without involving enforcers or government. I can pass a bottle of wine, anything. But land is where it is, and so an enforcer can always come to it and enforce his or her decision. So enforcer is gonna enforce, and if, for instance, you own some land, you sell it to me, you transfer the token, and I have the land, I have the token, and then comes an enforcer, and for instance, in their opinion, you were not owning that land legally, then they just tell me that this land is not mine, I go away. And there are two problems here. First, they don't care about the token. So I own the token, but they disagree with that, and that makes the whole system useless. And the second thing is even funnier, because the person who owns this land, like they think legally, won't be able to get the token because I won't give it. Okay, the second thing here is centralized development and maintenance. For now, usually enforcer is the one who keeps land registry, I mean government, regulator, call it what you want. And this means that enforcer will decide what system to use, and enforcer will develop and maintain the system, which also means that this whole idea is useless here. Okay, the next use case is ICO. Please don't laugh here because it's real. I think this is a use case, not a good one, but a use case. And this use case was inspired by recent pretty successful BitTorrent ICO. So it's still here. There are two problems here. So people collect money from crowd investors, and after that people do nothing. That's not pleasant. There are two reasons for that. First, smart contracts are not enforced. They do not enforce themselves because, let's say, a venture investor can come to his team, to his startup and say, hey guys, I want you to work, start working. Smart contract will never do that. And second, if we talk about, for instance, IPOs, then the people who collected this money, they will answer for their actions to an enforcer. This problem could be solved by decentralized institutions, and I hoped it will, like Reputation and some others. However, they are not here yet, so this problem is not solved, and that led to what we saw during the ICO boom, Lambos and all that stuff. Okay, the next one is actually not a use case, but it's a real scenario. Let's say we have some obsolete process in an enterprise, and there is an entrepreneur who wants to fix this, to want to digitalize that process to make it like it should be. He or she comes to a decision maker to get funding and tells them that here we have great solution for saving money, for improving our processes and so on. However, he or she might hear no, because decision makers are often very conservative people and they're not ready to invest money in just some little improvements. They want to get everything. So if this person just only adds a word blockchain in his or her suggestion, they get funding. I don't think that that's bad if the people really understand whether the blockchain is needed there. I think improvement is good, and I'm not the one to judge these people. So let's go to the last one, which is money. I think no one will ever argue at this point that this use case already works, is already in use. However, there are some arguments about what qualities these or that money should possess and so on. I don't want to talk about this now. I just want to give two little considerations here. First is that actually money is a use case of smart contracts, because a simple money transaction, a money transfer, is a trivial form of smart contract. And the second one is that we do have an engine here. I mean, we do have a perfect oracle, which is proof of work, because proof of work actually puts into a blockchain an information about real world, because if miner has created the block, then it means that this miner has enough physical computational power to do that. So we get real information about physical world in the blockchain. That's pretty funny. Okay, so these are not just any final judgments. I will be happy to hear from you that I'm wrong, that some of these use cases work, that I have not named all the problems or all the solutions, or maybe that oracles already work. So any feedback, any questions appreciated, maybe now, maybe by email or Twitter. I will be really happy to hear any considerations about that. And just a bit of additional considerations and dreams. I love smart contracts. I think that this technology is really great, and it will have its applications in the future, of which we can dream right now. However, what do we need now for this thing to be great in the future? First, we need reliable oracles, as I have shown. Then we need new use cases, not only improving old processes, like I have said, but also some new use cases. Because, for instance, no one ever dreamt about social networks. They just appeared, and they do not correspond to anything that existed before. And also we need testing hypotheses. So after we find some use case, we need to find out whether people need that thing, which is pretty complicated for an immutable software, but this is a topic for a whole new talk, as well as reliable oracles, as well as new use cases. And also definitely there are reasons, there are things we need of which I don't know. And that's why I don't know about that. So this is the picture of some old website and some new website to show us how things change with time and to give us inspiration to work on technologies to bring something really beautiful and new. Okay, and here I want to say that everything that is possible now someday was impossible. So that means that in some point of space and time it became possible. And also this means that there were people who made this possible. So let's be that people. Let's be dreamers. Let's dream about something great, about flying up in the sky, and let's do something like the Wright brothers who created the first airplane. So thank you. Any questions, any feedback appreciated. Thank you for the time.